All right, hello everybody. Today, I have day one and day two in the same video. I'm sorry this time, but it's kind of the same deal, and it goes by pretty quick. Um, so, really, with integration, there's not a whole ton of different like trig stuff, like we had to learn that the derivative of sine is cosine, the derivative of cosine negative sine, the derivative of natural log is 1 over x, derivative of a to the x is ln of a times a to the x times the derivative of the exponent. There's not a whole ton of rules that necessarily go with integration. It's just kind of using what we know to rewrite them. So what we're going to be doing today is integration by substitution. A lot of the times this is called U substitution. And the reason being is because a lot of people will use U. And I'll use U as well. I think that's what Mr. Osborne uses too. That's what you guys will see in most textbooks is like a U and a V substitution. This will be useful when you get to the first real lesson of Cal 2, which is integration by parts, which, again, you'll learn that in Calculus 2. So, essentially, you will have find the following definite integral or find the integral in general. And notice here, right, we can multiply all of this out. This is x squared plus 1 to the fourth. So I can multiply that out. I could use Pascal's triangle if I wanted to, and then distribute the 2x all throughout. But I really don't want to have to do that. So one thing we can do is check this out. If I like if I let u equal x squared plus 1, and if I take the derivative of that, the derivative of u with respect to x is 2x. So if I multiply up this dx, then I have du equals 2x dx. Well, that's pretty interesting, right? And the reason I say that that's interesting is because 2x dx is right here. 2x dx, without that fourth, right? And then the other thing that I have here is I have u is x squared plus 1, so u is that junk inside. So the only thing that I am not messing with really is that exponent of 4. So if I rewrite this in terms of u, then I would have the integral of u to the fourth du. Right, because that's saying 2x times dx, 2x dx is du. Well, that integral is not that bad to do, right? Because that's just u to the fifth over 5 plus c. That one's pretty easy. And then what we can do is, since u was x squared plus 1, take that u, substitute it back in for u, and all this is x squared plus 1 to the fifth over 5 plus c. So much easier than multiplying all of that stuff out. So kind of what I was looking for in this was to have something that I can take the derivative of such that it leaves me with a part with my dx. There's going to be different ways of looking at it. This is one of the more basic ones. Because if I take the derivative of 2x squared, it gives me both the 2 and the x and the dx. It gives me everything that I'm looking for. Some instances we will need to rewrite this out a little bit differently. We'll have different things that we need to substitute. There's just going to be different characteristics that we'll pull in with this. Yeah, I can't think of anything else, but if you guys have questions, that's why I like in-person class so much, you ask good questions. But all we are trying to do is find a good u, then make the substitution with du, with the dx, integrate in terms of u, don't forget your plus c if you're doing indefinite, and then substitute the u back into your antiderivative. That is our main goal. Okay, moving on. The next one is also not so horrible. right? If you haven't been pausing the videos on these things, I would highly suggest you guys pause the videos each time I get to a new problem. But what I would do is I would let u be the entire thing on the inside of my square root there. You could let it be just the x cubed, but then you would have an x cubed, like a u cubed or a u plus 1 under that square root. So it doesn't really work out so nicely. That's one question that I would get, is why can I make the u just be x cubed? And yes, you can, but you're going to want to do another substitution. You'd want to do like a v substitution or something like that, because that plus 1 under the square root is really an issue. And when we take the derivative of a constant, it becomes 0, so it kind of takes care of itself anyways. Then I will let du be 3x squared dx. Notice all I did was multiply over the dx. That'll be the same thing every time anyways. Okay, so 3x squared dx is all of this part, so really what I have left is u to the 1/2, it's just square root of u, du, and that is equal to u to the 3/2 times 2/3 plus c, and then just put in your x cubed plus 1 to the u spot. And if you want to rewrite this using your rules, you could see this as something like that on the free or on the multiple choice, right? You can also leave your answer like this on a free response question. The only thing you need to make sure that you do is don't leave that u. That is not good enough. We are asking you to integrate in terms of x. So you need to give us our indefinite integral in terms of x. Okay. So this one, again, you can multiply out that secant squared if you want to and do different things and yada, yada, yada. But what I would do is I would take my u to be tangent x plus 3. So I'm going to say off to the side, let u equal tangent of x plus 3. And you do need to let the reader know what you are using as your u and show them what you are going to be substituting as your du. Right? Because du is secant squared of dx, u is tangent of x plus 3. So what I'm going to also say is that I'm really doing the integral of just u du. They also want to see that substitution. Don't just go straight into the antiderivative at that point. You need to show the work that led to the answer. So then show them that this would be u squared over 2 plus c. And then we can make the substitution back in for tangent of x plus 3 squared over 2 plus c. And that would be it. Alrighty. Okay, here's one we're going to do a little bit more, but it's still not horrible, right? It's similar to that first one that we did, right? The x squared plus 1 to the 4th. But notice the only difference is that 2x on the outside. I don't have a 2. So let's kind of see how we can mess with that. What we can do is I'm still going to take the u to be my x squared plus 1. And then that would mean du, 2x dx. So notice this 2 is missing, right? I don't have a 2 anywhere in my equation, or in my integral. So what I can do is I can move that around. I can kind of finagle this and say that, well, du over 2 is x dx, such that my x dx is all right there. So instead of my x dx, I will have du over 2. So what this becomes is the integral of u to the 4th du over 2. And what I like to do is I like to take that 1/2 outside of my integration symbol. So I still just have u to the 4th du. So then this would become u to the 5th over 5, so u to the 5th over 10 plus c. Make the substitution back in for your x squared plus 1. And there you have it. Okay, so even though the entire 2x dx did not show up, all I needed to do is divide over that 1/2 so that the 1/2 ends up multiplying with my integrand. Alrighty. Going to be the same sort of deal with this. So again, if you haven't paused the video yet, pause the video, try this problem, see what you come up with, and then watch. So u would be, and I always say let u equal, just so it's very easy for the reader to follow what I'm doing. 3x squared dx. So what I need to do with that 3 is I need to do 1/3 du equals x squared dx. And I can make the substitutions now. So I have 1/3 integrand of square root of u du, which would be 1/3 times 2/3 u to the 3/2 plus c, and then make your substitution for x cubed plus 1. So we have 2/9 x cubed plus 1 square root of x cubed plus 1 plus c. Okay, and that simplification goes back to the same deal as this other simplification up here. I'm going to have it to the 3/2, so I can take out one of them and leave one of them inside that square root. All right, is that it for day one? No, we got a little bit more. So let's see, that is cotangent, cosecant, so let's see, that would be negative cosecant plus c. Yep. All right, so let's show you with u substitution that we will come out with negative cosecant plus c. So in this case, I would let u be just sine of x. So that way du is cosine of x dx. So again, notice that means that I would have a u squared in the denominator, and my cosine of x dx is all right there in the top. You could not do cosine and then have it be 1 over sine dx or something like that, because it wouldn't be 1 over sine dx, it would just be sine dx. All right, so one question that could be asked is, can I use sine? The answer is no. If I try to use sine, sorry, can I use cosine? I'm lying. Ah! Right, so I'd have negative sine. The issue here is that in my integral, this is 1 over sine. So this is just sine of dx, and it doesn't really work out. You would actually just be creating more sine of x's in your integral. So that one would be no bueno in this case. All right, so then I would have the integral of 1 over u squared du, which would be negative u to the negative 1 plus c. So this would be negative 1 over sine plus c, which is negative cosecant of x plus c. All right, so there's kind of the u substitution. Really, the trick that I want to show you here is you don't have to take the whole term. You could just take the sine, and that way it's still just a power rule, kind of like what we were doing before, except the inside function was like a x squared plus 1. I wasn't taking x squared plus 1 to the 4th, it was just the inside part. It's going to depend on what part you want to take as far as what you are seeing in the problem. So really just the best way to get better at these things is to practice them. All right, I think that's it for day one, so I'm going to go ahead and get into day two. Day two. So still doing the same idea, but the cool thing here is this is interesting. I have an x and I have a 2x. So let's see what happens if I let u equal 2x minus 1. Then du would be 2 dx, which I don't really have, so I want to have du over 2 equals dx. But this x isn't really taken care of. However, something cool that I can do is I know a relationship between u and x. Right, I defined that relationship right there. So what I could do is say that if u is 2x minus 1, then u plus 1 over 2 is x. And what that allows me to do is to write my integral all in terms of u. So I have 1/2 u plus 1 square root of u du with another 1/2. Right, so I have a 1/2 here and I have a 1/2 here. So these will multiply together to be 1/4 on the outside there. And then what I will do is what we were doing in the last one, which really you could have done first in this one. It's not one that you need to use u substitution for. I just want to show you kind of the idea that you can do. But this would be 1/4 the integral of u to the 3/2 plus u to the 1/2 du. All right, so I have 1/4. And then this will be 2/5 u to the 5/2 plus 2/3 u to the 3/2. And then it doesn't matter where you multiply the u or the c by 1/4 or not. Then go ahead and substitute your u. So this would be, let's see, 1/4, that'd be 1/2, so 1/10 u to the 5/2 plus 1/6 2x minus 1 to the 3/2 plus c. Alright, so these can definitely get kind of ugly as you go through these things, but just really take your time, think about what is multiplying to be what, and if you're on the multiple choice, you really got to check your answer choices. Because I could totally see them doing like +1 in there. I could see them doing 1/20 and 1/12. Or they would keep one of them the same and just change the other one. So just be very careful, be very tedious about the options that you are choosing. Okay, same idea here. I don't like this 2 minus x under the square root, so I will say let u equal 2 minus x. That would mean du is negative dx. So I'm going to make negative du just positive dx. And that means that x is 2 minus u. Oh no. So this would be the integral. I'm going to pull out that negative, and x plus 1 would really be 2 minus u plus 1, and then u to the 1/2 du. Yeah. So just take your time in the substitutions too. I got to really think about this and make sure that I'm doing it correct. One, because I don't want to mess up in the notes video. So that's no bueno. And two, because I don't want to get the problem wrong. So really, really take your time. And I don't even like talking to you guys while I'm doing this, so I hope I'm not messing up. But take your time and make sure that you are multiplying all of those correctly. Okay, so now that we have that, then we can do the antiderivative. We can differentiate. So I'm going to leave the negative factored out of this whole thing. Let's see, 3/2, so 2/3, so 4/3. U to the 3/2 minus 2/5 u to the 5/2 plus 2/3 u to the 3/2, and then plus c. It doesn't matter if you put it on the inside or outside, it's just a constant. And I would probably just leave my answer like this essentially, but I need to go back and substitute in my u. So it's just a lot of writing. Fun times. Okay, now I'll go ahead and distribute the negative. So 4/3, 2 minus x to the 3/2 plus 2/5, 2 minus x to the 5/2 minus 2/3, 2 minus x to the 3/2 plus c. This would be your answer right down there. Again, they could rewrite that with the square roots and stuff. Just be careful. Take your time as you're going through those. Okay, now I think we only have 2 more examples, and you're going to kind of see how U substitution works with definite integrals as well. So we can actually do something pretty cool with this stuff, but looking at this function right here, what I would do is I would let U equal 1 plus the square root of x. This is pretty ugly, at least in looking at the first. But just remember this, the derivative of root x gives me 1 over 2 root x. So I know this 1 over root x will be involved with my dx term. So let me show you. All right, because then du would be 1 over 2 root x dx. And then I would want to multiply over that 2. So make this 2 du equals 1 over root x dx. So 1 over root x dx is this part. I have u to be this part. So really I just have this as 1 over u squared. So now the other thing that we need to think about this, especially since this is a definite integral, is I'm going from when x is 0 to when x is 1. So nice thing, one, you need to be careful. There are 2 options here. One, you can leave the limits off. You can leave 0 off of my next integral, and you can leave 1 off. So you would just write an integrand something like that. 1 over u squared du times 2. And you can leave it like this and then do your integration, do your u substitution back in, and then use the first fundamental theorem of calculus to do f of b minus f of a and find what your answer is. However, what I prefer to do is actually just change my limits. Because if this is in terms of x equals, and I've since changed it to u equals, what I can do is if I take this x equals 0 and I substitute it into my relationship, this would be 1 plus 0 is u. So this would be from when u is 1 to when u is 2, right? So I'm substituting in 1. 1 plus square root of 1 is 2. So this is going from when u is 1 to 2. So now I actually don't have to go back and substitute back in my u substitution. So let me show you how that works, what I'm talking about. So this would be 2 times the integrand, so the antiderivative of, let's see, that'd be u to the negative 1, so negative 1 over u. I don't need the plus c, but from 1 to 2. And I don't need to substitute back in x. If I substitute back in x, then I need to change my limits here. So you could do that. If you substitute back in x, you would have 0 and 1, just like your original integrand. But you could also just leave it in terms of u and do it in everything in terms of u. So it's actually less work if you do that. So I'd have negative 1/2 minus, so plus 1 over 1. So this would be 2 times 1/2, which would all come out to be just 1. All right, so again, I would pause the video if you have not already. Give it a shot, see what you guys come up with. Okay, here we go. Oh! So in this one, I would let u equal 2x to the 4th plus 1. And that would mean du is 8x to the 3rd dx. So I only have an x to the 3rd, so I have 1/8 du equals x to the 3rd dx. And I would change my integrand as well. So I have the 1/8 out there. And on my integrand, that's a super ugly one, but I have 1 and then 2 times 1 to the 4th, so 2, so 3. And this part is du. So I have u squared du. Right, so then 1/8. Yikes, come on. So u cubed over 3 from 1 to 3. So this is 1/8 times 3 cubed would be 27 over 3. 27 over 3 is 9 minus 1/3 times 1/8. So let's see, 9 times 1 or minus 1/3. So 9 would be, I might just did it, 27/3. Yep, so 26 over 3 times 1/8, so 26 over 24, so 13 over 12 is how you would see that on a multiple choice answer. Again, Free response, you can leave your answer like that and receive full credit. That is a free response answer. Multiple choice, we'll have it as this. This is not a good enough answer. You need to evaluate that thing. You need to get rid of all your variables there. Okay, other than that, that's really all I got. It's just going to take practice on this stuff. But U substitution is very important moving forward. It's going to help you when you get to much more difficult integrals. Some of the ones on homework are going to be a little bit tougher, but that's just because you guys haven't had enough practice with it yet. So keep getting practice, and then let me know what questions you guys have, and I will talk to you all soon. Bye.